My name is Shashank. I'm with the Cisco TAC LAN switching team. I've been working there for the past 3 years, and today's video is to demonstrate the process for an upgrade for the 4500 chassis. We shall be covering two scenarios. The first one, a single soup, and the next one would be a dual soup. So let us begin. I have a 4507 chassis with a Supervisor 4. The first step for any upgrade is to download the required iOS image. So let us go to the Cisco download page, and here it is. We'll be upgrading today from the SG7 train to the SG8. Before downloading any iOS image, always look at the DRAM, the flash, and the size of the iOS. Also note the MD5 checksum. It will be required at a later stage. Also useful are the release notes for that particular iOS. Sometimes, before an iOS upgrade is done, a ROM1 upgrade is also required. So all the details of that will be mentioned in the release notes. So let us begin. The first step is to copy the iOS image. Today I shall be using a TFTP server to copy the iOS image. First, let me check the reachability towards my TFTP server is working fine. The ping is successful. Let's start the copy of the image. I have the boot flash directory where I need to copy the image to. I have my image, the SG8 bin file, and this is the destination which will remain the same. And here my TFTP copy has started. Also, besides using the TFTP server, some supervisors have a management port, some supervisors have a USB drive port. They can also be used to copy the iOS. Alright, so it seems that the iOS copy was successful. Let us verify. I do a directory boot flash and I see that the new image is already there. The next step is to change the boot variable to point towards the new iOS image. Let us check the current boot variable and it is set to SG7. You can also do a show run include boot to check the boot statements already present in the system. Let me first remove all the current boot statements which are already there. A no boot system should clear that. Let me now put the new boot statement, which is boot system boot flash and the iOS name. Very important after this step is to save doing a write mem. That is done. I verify that the boot variable has changed by using the show bootvar command once again. This time I can see it is pointing to the SG8 image, which is what we require. Also note the config register value. This should be 2102. If not, you need to change that as well. Once that is done, the next step is the easy part. You issue a reload command and the booting process will start. Alright, it seems that the boot process is ended. Let us verify that the iOS was upgraded successfully. A simple show version command will show you that we are currently running the SG8 train, which is what we required, and the upgrade was successful. I hope you found this useful. The next part will cover the dual soup. Thank you. Alright, so the next part of the video shall cover the upgrade process for a dual soup scenario. As you can see in my setup, I now have a dual soup, soup 4s in a 4507 chassis. So the next step would be to copy the iOS image into the boot flash of the standby supervisor. I've already copied it into the active in the first part of the video. So I initiate the copy now to the boot flash of the standby supervisor, which is referred to as the slave boot flash. Put in the source file name, which is SG8. Destination remains the same, and I start my copy. Now you can do an internal copy as well as a copy from the external TFTP or any other source into the slave boot flash as well. The iOS image has now been successfully copied to the boot flash of the standby supervisor as well, and let us verify. I do a directory slave boot flash and the SG8 image is there. The next step is the same as it was in the single soup. I changed the boot variable. So I go into configuration mode. I remove all the existing boot variables with a no boot system. I put in my new boot statement, which is boot system and a boot flash. And I put the iOS image SG8 and I do a write mem. You only need to set the boot variable for the active supervisor and after you do a write mem, the configuration automatically syncs to the standby. Now let's verify with the show boot var, and we can see that the boot variable is set for the active as well as the standby. Both of them should be the same. After this, the next step, as was for the single soup, involves a reload. Now here you can take two directions. You can reload the whole chassis, that is both the supervisors will simultaneously reload and upgrade. For that, the command is a redundancy reload shelf. Be careful not to use the reload command only. That will only reload the active. So here I proceed with the first way to do this, which is the redundancy reload shelf, and I initiate the command, and now both my supervisors have reloaded simultaneously, and both of them should come up simultaneously with the new SG8 image. Alright, both of the supervisors were reloaded and they have booted up. So let us verify if the supervisors were successfully upgraded to SG8, and we can see in the show module output, both of them are in SG8 train and they are in standby hot. You can also do a show version and confirm that. Here it is SG8. Now the disadvantage with this process is that when you reload both of them simultaneously with the redundancy reload shelf command, there would be a complete outage in your network since both your supervisors have reloaded. Now there is also another way to reload the supervisors one by one, and so the outage time will reduce, and the only outage you'll see would be when a failover is done, which should theoretically be around 5 seconds to 30 seconds. So the way to do that is as follows. So now first I will reload only the standby supervisor with the redundancy reload peer command. Once that is done, the standby supervisor will reload and will upgrade to the required iOS version. Once that is done, you can do a redundancy forced switchover. Now this will reload the current active, and the standby, which is already booted up with the new iOS image, will take over as the active. So this process involves reloading the supervisors one by one, and once that is done, the outage time reduces. So you can use this method as well, and your outage will be a lot lesser than reloading the whole chassis. So this was about it for the dual supervisors and the single supervisor upgrade process. I have demonstrated only for the supervisor 4, but this is also applicable for all the supervisors available in this 4500 chassis like Soup 6, Soup 7 and Soup 8. I hope you found this video useful, and all the best with your upgrade. Thank you.